Hello everyone, Professor Khan here, back with another example. We are solving a cubic equation today. X to the third minus 2x squared minus 58x plus 35 is a third degree polynomial, which means that we have to factor this in order to solve it. Factoring and then using the zero product rule, and then the zero product rule is usually how we solve these things. Again, if it's factorable, then that's a good thing. Not all of these equations are factorable. This one happens to be. So a nice little hint that we have here is that we already know that x equals -7 is a root. We're given this as a function. It's not set equal to 0. But knowing that x equals -7 is a root is going to help us later on when we do solve this. The proof of this happening is the remainder theorem, something that we talked about in class. The remainder theorem says that if f of -7 ends up being 0, then that means -7 is indeed a root of our original f of x. So let's evaluate f of -7. That's going to be equal to -7 to the third power minus 2 times -7 squared minus 58 times -7 plus 35. This is our original f of x with -7 plugged in for all of x's. Evaluating this using grouping, then exponents, -343 is the result of -7 to the third power, minus 2 times 49, minus 58 times -7 plus 35. These remain untouched because we did not do anything with it yet. We will get to it later on. But we did exponents first because that's what's supposed to come first. Multiplication is next. So -343 minus 98 plus 406, the result of -58 times -7, plus 35. And we can add all these together and it gets 0. This checks off that -7 is indeed a root of f of x right over here, this polynomial. So if x is -7 is a root, right? We know that x equals -7 is a root. Then this here is us using the remainder theorem. In order to figure that out, in order to confirm that. We can use the factorization theorem to determine that if x equals -7 is indeed a root of f of x, that means x minus this value is a factor of f of x. And x minus -7 can be written as x plus 7 because those two negatives make a positive. So we can extend this further. Again, let's go back a minute. Knowing that -7 is a root of our original polynomial tells us that we can write a factor of this polynomial, f of x, by writing out x minus that root number. That turns into x plus 7. How does that help us? Knowing that x plus 7 is a factor, that means we can take x to the third minus 2x squared minus 58x plus 35, our original f of x polynomial, and we could divide by this root f x plus 7. Right, so we can divide by this factor of x plus 7. How does that help us? For example, if we take 28 divided by 4, that answer is going to be 7, right? Without a remainder. A remainder is going to be 0 because it divides cleanly. This means that 4 and 7 are factors. And that means that 28 can be rewritten as 4 times 7, and there's a whole bunch of examples using actual numbers. That concept holds true for polynomials as well. So if we do this division over here, f of x divided by a known factor, x plus 7, the result is going to be another factor. It's going to be the factor pair of x plus 7. That division is done here. Let's walk through this division. We got our original polynomial, f of x, inside. We got our divisor, x plus 7, outside. And we start over here by taking x to the third divided by x, the two leading terms. That equals x squared, and that gets placed up here. The next step is to distribute, multiply x squared times x plus 7. That's right over here. That result is going to be x to the third plus 7x squared. The next step is to subtract. We are subtracting these two polynomials here, x to the third minus 2x squared minus x to the third plus 7x squared. And that subtraction is done here because this minus sign distributes. The result, because x to the third minus x to the third is equal to 0, that result is going to be negative 9x squared. That's negative 2 minus 7x squared. Right, negative 2x squared minus 7x squared is a negative 9x squared. Bring down this 58, negative 58x, and these three steps happen over again starting with this new number here, negative 9x squared divided by x, negative 9x. And that gets placed up here. We distribute negative 9x times x plus 7. Negative 9x squared minus 63x is that result. We're subtracting, which means we are distributing this minus sign over here and then adding and combining all those like terms. Negative 9x squared minus plus 9x squared is equal to 0. And negative 58x plus 63x is equal to a plus 5x. Plus 5x is that result. And 35 gets brought down. And again, we go through this process. 5x over x is equal to 5. So that's how we get this plus 5 up here. We do that distribution, 5 times x plus 7 is equal to 5x plus 35. We subtract 5x minus 5x, and then 35 minus 35, and that answer is 0. That's the remainder. We already knew the remainder was supposed to be 0 because, again, we were told and we figured out that x plus 7 is a factor. So here's what that means. That means that our original f of x polynomial, x to the third minus 2x squared minus 58x plus 35, now also equals, can be rewritten as x plus 7 times x squared minus 9x plus 5, which is the quotient that we got up here. Our original polynomial is given to us in standard form. After figuring out this factor here, and using division to figure out this factor pair, we have now written this polynomial in factored form. Now, how does this help? Because again, being able to write an equation in factored form after it is set equal to 0, such as this equation, our f of x polynomial set equal to 0, and this is our process of what we do in order to find the roots. means that we have x plus 7 times x squared minus 9x plus 5 equals 0. And everything is coming up Milhouse. Because now we can solve this cubic polynomial set equal to 0 by solving a linear equation and also by solving a quadratic equation by using the zero product rule. The zero product rule, remember, lets us set one of each of these factors equal to 0 and solve them independently. X plus 7 is a linear equation. X is equal to negative 7. That's one of the roots. X squared minus 9x plus 5 is a quadratic equation. We can solve a quadratic equation a number of ways. We can factor using the AC method. We can complete the square. We can use the quadratic formula. This equation, this polynomial is not factorable. There's nothing that's going to multiply to 5 and add up to a negative 9. So we can go ahead and not go down that route anymore and waste any time. In addition to that, we can calculate the discriminant b squared minus 4ac, which is going to be, after figuring out that a is equal to 1 and b is equal to negative 9 and c is equal to 5, the discriminant tells us negative 9 squared minus 4 times 1 times 5, 81 minus 20 is equal to 61. This is a positive, non-perfect square, which means that this equation is not a factorable quadratic equation. So let's go ahead and jump into x equals negative b, which is a negative 9 plus or minus the discriminant 9 squared minus 4 times 1 times 5, all of that over 2 times 1, which is 2 times a. X is equal to 9 plus or minus the discriminant, which we calculated here and got 61, divided by 2. And since 61 as a radical is not simplifiable, if that's even a word, can't be simplified, that means we are done. So our roots, our answer is to this equation is going to be 7. It's going to be 9 plus radical 61 over 2. It's going to be 9 minus radical 61 over 2. Thank you for watching.